right, new day, new Alienware to repair, and this time we have an Alienware M15R7. This is the Ryzen edition. The customer said that they were playing a game and the laptop suddenly shut off, and when it turned back on, they said that the charger light is on, but then it doesn't turn on or doesn't charge the battery. So I haven't looked at this yet. Let's take a look together and see if we can get this figured out. All right, first thing we're gonna check here is see if it turns on, and it is not turning on. All right, let's plug in the charger and see if it pulls any current at all. So keep an eye on the power meter here. And it's pulling 0 amps. So in general, what should happen when we plug this in? It should the amp should come up to 0.01, 0.02. That turns on the LDO, which is the linear voltage regulator that powers the EC chip. The EC chip is the embedded controller, which is like a little microcontroller that's running a little loop of code that handles the turning on, detecting the power button and turning on different power supplies. It actually reads the keyboard. It does a lot of different things. And so that thing's always on when the machine's off. So we should actually be sitting here at 0.01, 0.02. So if we're sitting here at 0.0 when I plug this in, most likely there is a short on the motherboard, probably on the main power rail when it's like that. So, but the good thing that I'm seeing here is that because the charger light has not shut off, that means that most likely the protection MOSFETs are shutting off the voltage from getting to whatever shorted out, so it's not damaging anything further on the board. So let's go ahead and open it up and see if we can figure out what's going on. All right, the bottom is off. All right, let's take a look real quick. Here's the main battery. It's a Dell Genuine, has the serial number here. And if you're interested in getting any parts for your Dell laptop or Alienware, my company specializes in Dell and Alienware parts. So we have more than 700,000 parts in our warehouse. You can order it shipped same day, you get a year warranty, and everything's guaranteed Dell Genuine OEM with the serial number and everything. We also see, look at these memory chips. They actually have their signatures on them. So I wonder if these are custom or something like that. Just kidding. There's also signatures on the motherboard too, so I'm not sure what's going on with that. There's the NVMe drives. This one actually has this populated. This one is not populated. This is just a heatsink. So what we're interested in is where the DC jack goes. So we have the DC jack here, and the cable's routed through here and plugs into the motherboard right there. So, and if we take a look, you can see that there's going to be a set of MOSFETs. Here's a pair here and then another pair. So the circuit usually it will energize this area right here, go through a couple inductors or a few inductors, and then go through a pair of MOSFETs and then another pair of MOSFETs, and then that will energize the main power rail. And so if it's detecting a short somewhere on the board, it usually will shut off one of these pairs. So let's get under the microscope and let's take a look and see how far the voltage is going. All right, if we take a look here, so this is what I was talking about. So here's the DC in jack. We're gonna have, you can see this big pad here. This is gonna be the positive 19 volts. This is gonna be the ground, and this is gonna be the PSID pin. On these laptops, they have a PSID pin, which is a communication pin where the charger communicates with the laptop, tells it what, how many watts it is and things like that. So we have the voltage which should come through here, go through these 4 inductors, then go into these pair of MOSFETs. And then after it goes through these MOSFETs, it will come out of these 2 and then go into another pair, and then go through this current sense resistor, and then energize this area right here, which goes through another set of inductors, and then a couple other current sense resistors. This is the inductor that for the charging IC for the battery. And then these are going to be the MOSFETs that charge the battery. So let's go ahead and plug in the charger and see how far the voltage is getting. I'm going to unplug the battery at this point. That way we take that out of the equation. All right, I got the charger plugged in. We're still not pulling any amps with the battery unplugged. So I have my voltmeter in voltage mode. So we're going to detect if we have 19 volts here, and we do, 19.73. It's going to go through these 4 inductors, and we should have voltage there. And then it's going to go through this pair of MOSFETs, and let's see if we have voltage on the output of that. And we don't have any voltage on the output of that. So the way a MOSFET works is just like an on-off switch, and there's going to be, on this particular pair, you got 4 input pins, and then you have 3 output pins, these, and then you have the gate pin, and that's kind of the on-off switch. So if it's either high or low, it will tell it to turn on. So if we measure that pin right now, we are getting 0 volts on that gate pin, which means that this would be an active high in order to get the voltage to go through here, and it would have to be 25 volts in order for it to allow the voltage to flow. So we should be getting 25 volts on this pin. We're getting 0. So these MOSFETs are set to be off right now because there's probably detecting a short somewhere, but let me show you which chip is responsible for that. So this ISL chip, which is a 95522 chip, this is what's actually in charge of running all these MOSFETs over here. It handles the battery charging, it handles the protection, creating the main power rail. It's reading current on these current sense resistors and figuring out if the current is too high, then it shuts off the circuit. So with all that said, we haven't measured yet for a short, but I almost 100% think that there's going to be a short on one of these current sense resistors. So let's go ahead and get into, I'm going to unplug the power. I'm going to put it in continuity mode where if I touch the probes together, they beep. And we're just going to check. I'm going to just start back here just because I want to walk us through this. But so we don't have a short here. So we're going to go through these and we check right here. And we have a 8 ohm, 8.7 ohm short right here at this current sense resistor. And what about this one? We have an 8.5 ohm short. So we do have a short in this area. This should actually be reading something probably in the mega ohms, and there shouldn't be any type of a low resistance of 8 ohms. Now, when we're measuring 8 ohms, that's not like 1 or 2 ohms. That's not like 0 ohms. So it's not a dead short. So it's actually kind of good that it's an 8 ohm, because if we were measuring something like 0.5 or 0.3 or something like that, that would be a short probably on the GPU. If we were measuring something like 1.7 or 2 ohms, you could possibly have a short on the CPU, which is the Ryzen chip on this one. So having 8 ohms, that's actually pretty good. We could just have a shorted resistor, or not a shorted resistor. We could have a shorted capacitor somewhere. I don't really know. We're gonna have to look around, so I'm gonna have to pull this board out and we'll take a look and see if we see anything physical, something burned up or something like that, because it could just be a chip that's actually burned up and needs to be replaced. But and we're probably going to end up having to use voltage injection, current injection, in order to figure out where the short is. And we just inject a low voltage into this point right here, and then look under a thermal camera and see what heats up. So, but what I want to do to continue, since we know the short is here, I don't need to look anywhere else. I'm going to go ahead and pull this motherboard out, and then we can take a closer look. So I'm starting to take the screws out of here, and I noticed that we already have some screws missing. I can tell that somebody's actually been in here. So this might have been taken to another shop. Just something to be aware of, that somebody else has probably looked at this. So, all right, and the motherboard is out. All right, I just want to take a quick look around, see if I see anything noticeable. I see a little bit of hair. The heat sinks aren't super dirty, but I can definitely see that there was quite a bit of dust in these cracks right here. We had to remove the fans to see how much actual dust and fur is in there, but because it could be an overheating issue that actually caused this problem. Let's get under the microscope. We'll take a look around real quick. Actually, I'm going to go ahead and pull this heatsink off before we start looking around, because it takes up so much of that whole side there. The way these are plugged up, it's like the fans plug in on one side and then the heatsink's on the other side. It's the most ridiculous thing ever, because if you ever wanted to take this heatsink off, you have to take the entire motherboard out, and a lot of times people will forget to unplug these fans, and it rips the connector. So I'm going to unplug those now. All right, and whenever you take off heat sinks, it's very important not to just pry up and you'll bend the actual pipe. A lot of people don't think that there's an issue bending these pipes, but what ends up happening is that you'll make it where the heat dissipation can no longer make it to the end of the fins here. So you always will move this back and forth, and you're trying to break the suction, the stiction. See, so I'm moving it back and forth. Now it's starting to move, and then now I can lift it off. And now if I would have just lifted it up and taken it off, it would have ended up bending the heat pipes. So we got that lifted off. Let's see if this is original thermal paste. This looks like this has possibly been removed. The original thermal paste is kind of more like a sheet, and this looks like it is it actually was squirted on there. So All right, so here's the GPU. I'm not sure which one this one would be. This is probably a 3070 or 3080 or something like that. RTX 3080. This is the Ryzen 9, I think. Let's see what we got. Yeah, Ryzen 9. All right, so now let's just take a look around the board now that we have this pulled apart. So I'm just going to start up here at the top. So here's the GPU. There's the VRAM, and then these are the MOSFETs that power the GPU. Now you see all this liquidy stuff here. There's oil. This is all just from the thermal pad, so nothing to worry about there. What we're going to be looking for is anything that's discolored or burnt. See these coils? They're all the same color, so nothing to worry about there. We also want to see if there's any ripped components. So if since someone's been in here, someone could have ripped something out, but they said it happened after playing a game, so probably is a component that failed. So we're going to be looking for something that's burnt or cracked. You'll sometimes see these capacitors be cracked. So here's the CPU, here's the power stages for the CPU, and these are the monolithic power stages. Again, all these coils are the same color, not a big deal. This one's a little bit different color, but it's a different coil too. So I'm just going to keep looking around. This is a daughter board. I think this is all for the LED backlit keyboard stuff. There's the EC chip. Remember what I was talking about when we plug it in, it should pull 0.02. So when this thing is actually on and running its little loop of code, it's just a microcontroller that has GPIO pins. So this should be on, but it's not turning on because it's not pulling any current because we have a short. So you keep an eye out for something. I'm just kind of doing a quick once over. We're looking for any cracked capacitors too. We will probably end up using voltage injection to find the short, but it's always nice to be able to just find it without having to do any injections. Okay, so this little cover here just came off the board easily. Usually it's stuck on there very well, so when I pulled it off, it just fell off. I could see fingerprints underneath here. Should we get a detective to figure out who's been in here? So we know that somebody's been in here, and there's also signatures everywhere. So if someone's saying something, here's another writing on here. So I wonder if a repair shop had this taken apart and then they were just kind of marking everything to make sure that everything kind of goes back together. I'm not sure. All right, so now we're on the other side of the board. Let's continue looking around. We're up here near the LCD connector. There's the Alienware lights. There we go. Did we find it already? Boom. Haha. That's why we look around. So that is a cracked capacitor. And so what a cracked capacitor will do is, you know, a lot of times it will crack and then be completely shorted as a wire, and then it will measure like 0 ohms. But this one happens to be measuring probably 8 ohms. Let's check it out. 8.8 ohms. Well, isn't that special? Okay, so let's go ahead and we'll continue looking around, but I don't think we need to investigate any further. We know that that is measuring exactly the same ohms that we're measuring on the shorted power rail. But we'll just do a quick once over just because we want to do our due diligence. Okay. That's that input circuit that we were talking about. There's the DC in. We already looked over here. There's more signatures. Touchpad connector, keyboard connector. Okay, well, it isn't always that easy, but that's why we always look around. And now you know what to look for, right? So you can see the crack, the visible crack in that. Right here across this one side, you can see the crack. You can also see this whole corner. It almost looks like somebody had arced something across it. You can see this whole corner is melted. And it is on the edge of the board, so I don't know if someone at some point had like stuck a screwdriver in here trying to pry something up. I don't know. But let's get this removed, and then we will replace it, and everything should be good to go. We should be able to reassemble this and get it back to our customer. All right, we're gonna add a little bit of flux. Probably not needed for this, but it's always nice. When you put flux on there, it makes the solder flow very easily. We'll make sure to turn on our air for our lungs to protect us. I'm gonna use hot air. I'm just to remove this, 450, 60% air. We want to get in there, get out of there really fast. This board's really thick, so it takes a little while to heat up, and that's why we're trying to heat this up as fast as we can. Okay, we have it off. We can examine this a little closer if we want. You can see how tiny it is. You see that corner? See how it's melted in the corner? It looks like somebody touched it, and it probably blew up. That's what it looks like to me. You see the bottom of it? So, all right, well, let's get this replaced. We don't know what the value is, right? So there's two different ways to figure out the value, or three different ways, I guess. Because people ask us all the time, how do you know what the value is? So one way is, let's just take this component right here. It's probably gonna be the same value. We have to take it out of circuit, and then we can measure it, and we can figure out, let me turn off that. You can take this one off right here, and we'll take it out of circuit. We'll just set it off to the side for a second, and then we'll measure it and figure out what the measurement is. It's probably gonna be the same value that was for this one. Another way is actually having the schematics or board view that will tell us. And the last way is I just go and grab a donor board, because a lot of times I'll have the same donor board for this. So let's take a look and see if I have a donor board for this. So over here is all my donor boards. I've been doing this 20-something years, so I collect a lot of motherboards over the years. Not all of these are necessarily bad for parts, but all of them have some sort of issue at some point, and so we set them off at the side. These boards are gonna be pretty close. These are, I don't know if these are R5, R7s. This board actually looks the same. So let's look in that area, and we have that same component right there. So we can go ahead and just take this capacitor off of the board and then get that transferred over. So you can see here's our original board and here's our donor board. It's the same setup. So we're just gonna take that capacitor off of here. This board, I've already taken components off of there. I always mark the processor or GPU with this red marker whenever I've already stolen some components off of it. This board had a bad, I believe, GPU on it, so or a bad CPU. Usually when I mark the CPU, it's bad. So therefore the board is not repairable, and I could just steal the parts off. So we'll go ahead and get that transferred over. But do you think, shouldn't we test to see if the short's gone? I haven't done that yet. Let's go ahead and do that real quick. I just know the short's gone, that's why I haven't measured it, but it would, you know, probably be wise to actually measure here. Okay, so, and we're measuring 0, 0, 0, so that side must be ground, so this side would be the positive, and we don't have a short there, so let's go back and check the main power rail. Where's the DC input? Okay, so here's our input circuit, and you remember we had a short right here on this current sense resistor, so now we'll measure right here, and we don't have a short anymore. So I guarantee that this board now will turn on. When we plug it in, we'll see that 0.01, 0.02 turn on, the LDO, and then turn on the EC chip, and then the power button should work and everything should post. So let's go ahead and replace this capacitor, and then we can get this laptop reassembled and we can test. So I like to go ahead and prep the area here, so I'm gonna put some fresh solder on these pads, and that way whenever I install the new capacitor, it will just sit right on there perfectly. So we have that ready, and we'll take this one off. Again, I don't know what value it is. I haven't even measured it, but because we're using a donor board, it's the same value, so we can just transfer it over and we don't even have to think about it. If you have a board that has this issue, I mean, you really can just run it without it. It's not gonna hurt anything. There are a lot of other capacitors on this circuit. But if you wanted to figure it out, you can just measure the one that's right next to it, and that usually will be the same value. All right, we're installing the new one. Add a little flux. Okay, the short is gone. Will it turn on? That's what we're going to try to figure out. So let's go ahead and clean up the CPU and GPU, and we'll put some fresh thermal paste on it. I'm actually interested. I want to see if the fans have a bunch of fur in it. let me open these fans up real quick. These fans have little tiny screws. We'll just take these out, and I'm just going to fold one up and take a look and see if these have been cleaned out. It's always a good habit while we have it taken apart to go ahead and clean all this. It's kind of like changing your water pump whenever you're changing your timing belt. So, all right, it's kind of taped on here. Let me peel this up real quick. All right, and woo! Oh my gosh. Okay. Wow. I was not expecting this. Okay, so. Oh my gosh. Okay, so I was just gonna put thermal paste on here, blow out the fans and all that stuff, but look, get a load of that. That is crazy. Here, let's pick this up. Boop. I mean, that is the thickest. Oh my gosh. Do you want some of that? You want some? Or should we send this to the gooch collector? That's what we should do. Here, I'm gonna put it right here. I'm gonna send this over to Andy and see if he needs any extra gooch. So we'll definitely open this one up. We'll get these blown out. I'm gonna clean up the old thermal paste and put some new ones on there. Let's open up this other one. Do you think this one's gonna be worse? I mean, I'm not surprised that we had some sort of issue with the component blowing up. I'm surprised the CPU or GPU did not blow up or go out, or a MOSFET is usually what happens on those, but okay, here we go. Boop, 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 boop. And this one's bad, but it's not as bad. Man, get a load of that. That is crazy. I don't know. I think it's probably the thickest I've seen. Here, we'll get it under the microscope. We'll get a closer look. So here's what I pulled out. That's on one side, and this is on the other side. So that's, I would say that's a pretty good amount. So I'm very happy that we took a look at that. You want this? Okay, so I'm gonna send this over to Andy. Let me get a bag. I'm gonna send this over to Salem Techsperts, and he can dispose of it properly. Boop. Hazardous material. All right, so let me finish getting this all cleaned up, and we can get it installed, and we can test the board and see if it works. Oh, should be doing this outside. I need a mask. Like, the fans aren't even that dirty. It's crazy. It's like they must have blown out the fans but never took this thing apart. All right, we'll use my toothbrush here to clean this. All right, since we got the fans cleaned out now, we gotta clean off this old thermal paste. All right, I got some fresh thermal compound on the CPU and GPU. All right, let me get this motherboard installed and then we can test. All right, we got the motherboard installed. Let's go ahead and see if this thing's functioning. Okay, moment of truth. Keep an eye on the power meter. What we want to see if it's pulling any current when we plug it in. It's not doing anything. So it's still dead. Uh-oh, still dead. Let's measure and see how far the voltage is actually going. Was I too confident on that? It should have definitely been fixed. So let's see how far it's getting now. All right, so we have our 19 volts here. We do. It's going into this first MOSFET. Is it coming out of this MOSFET? It's coming out of the MOSFET now. It's coming over here to this current sense resistor. It is. It's coming over here to these current sense resistors. All right, so we have 19 volts on this. Let's figure out why we're not getting the EC chip's not coming on, right? Because it's not pulling any current at all. It should be pulling 0.01, 0.02 there. Let me see, let's measure the LDO, which is right, where's the LDO at? I'm not 100% sure where it is on this one. Let me figure out what voltage we have on the battery. We have 11.96, so it's basically a charged battery. Interesting. This is a strange one. Usually when a capacitor goes out like that and we resolve the short, there's not going to be another issue somewhere else. I'm wondering if there's a surge that went somewhere else. That's interesting. We have the power button plugged in. So it's not a power button issue because we're not even getting that 3.3, the LDO being produced, right? Which should turn on right as I plug that in. I should see current going up immediately, and I'm not seeing anything there. Well, I have to pull this board back out. All right, I haven't taken the board all the way out yet, but I'm kind of unplugging things, and as I go, I'll plug in the charger again to see if we are starting to get that. So I unplugged the junction board here to the keyboard and the touchpad, but now when I plug it in, we're getting it 0.01 and it drops back down. So let's see if we can get this to trigger on. It should actually be sitting at 0.01, but I have the power button plugged back in. Let's plug this in, and we're not getting anything. Okay, 0.01 again. So let me plug in, or let me go ahead and hit the power button real quick. Still dead. Okay, what do we got going on here? I've got to continue pulling this board, unfortunately. So let me keep doing that. All right, so I got the motherboard back out again. I left the DC jack attached so I can plug in and we can measure. And it's quite annoying because this issue should have been resolved by just removing that shorted capacitor, but we don't know why the EC chip's not coming on. So let's measure and see if we have any voltage around the EC chip. All right, we'll just measure some of these resistors and capacitors. Don't have anything here. Yeah, so we're not getting our 3.3 LDO to be active. We're gonna have to figure out where that is on this board. I thought it was over here. Could still have a bad power management chip. Let's actually measure these. Those are all working actually, because we have voltage getting all the way over to here, right? I'm just going to put it in continuity mode, make sure none of these are shorted open. Sometimes it will have an issue here. Okay, for a second it was measuring shorted, but it wasn't. Okay, so we're going to measure to the gate, that's fine. And these are fine, right? Okay, we don't have a short to ground over here because we know that we were energizing to 19 volts there. So what I'm looking for is that LDO, linear voltage regulator. See all this little dust here? This is that little pad that has like metal filings in it, which is kind of annoying. So the linear voltage regulator, a lot of times it's near the EC chip. There it is. Okay, so there's our LDO. Let me plug in the power real quick again. Got 1.2, 3.1, that's fine. 13 volts, 19 volts. So we have our 3.3 right here. So why are we not getting our 3.3 over here? Oh, we are, 3.4. This would be the main 3.3 volt power rail, which is, where are those located? Let's see, what are these coils measuring right here? Probably nothing, because I imagine these power some of the power stages here, but this is a strange one. And then I try to work with no schematics for the most part, because it's you don't want to get reliant or dependent on being able to only diagnose using schematics and board views, because they're not available for all systems. So this particular model, I don't think I have one for it. 19 volts. So everything's energizing over here, and we're just not getting all of the power over to the EC chip. I mean, I don't really understand. Do we have another short somewhere? The main power rail had that short on there, obviously cracked, but let's measure, we're in continuity mode again. Let's measure these coils. These are all different power. Oh, what we got? 0.0, 0.0504. I mean, that's a dead short almost. And that's measuring 0.01. Oh, 0.1. That's 0. So this thing is shorted completely. I don't know what this actually powers, but that looks like, that's our issue there. Okay. Let me pull the heatsink back off because we need to figure out where this goes and then see if we can figure out what's shorted. And I guess we had 2 shorts on there, which is crazy. Maybe one led to the other. Maybe, yeah, I don't know. That doesn't make sense. But it definitely was running hot because we saw that fur in the heatsink. So let me get this heatsink off. All right, we got the heatsink off. Let's take a look and see what that coil is energizing or what it's connected to. So we have a pair of MOSFETs here. And here is a main power rail of some sort. So we have no short there. I'm in continuity mode, so we have no short there. We have no short there. That's a ground. And so we're shorted on the output of this power supply. So whatever this connects to is going to be what we're having a short. So now I don't know what that's connected to. It's going into the board here. And so let's flip over the board and see if it goes somewhere we can see. Okay, so it goes over here. Okay, there's another 0 short. These are tantalum capacitors, so they're electrolytic. They usually go on a power supply for power rails for like the CPU or GPU. Okay, we might have to inject voltage, unfortunately. I'm not seeing anything obvious. I mean, this is the capacitor we changed out. Remember, it looked like somebody had touched it here. And we don't have the short there anymore. This fuse good? Fuse is good. Let's measure over here on these. See, we're at 5 ohms over here. We're not at 0 like we were measuring over there. 5 ohms. So the CPU is measuring around 5 ohms. And the GPU is 0.03. I'm sorry if that beeping is so loud. There's no way for me to turn it down. Okay, let's go ahead and inject voltage. Inject some current in here. We're gonna have to do that in order to figure out if it's actually going to the CPU or GPU, so. Let's get the thermal camera set up and we can continue. All right, we got the thermal camera set up. And so we're gonna end up injecting some voltage here and some current, some power. I'm gonna inject a low amount because we don't know what it's actually hooked to. And so we will go with 0.8. That's safe enough in case it's going to the GPU or CPU. I suspect it's going to pull a lot of current because it's a very low resistance. So let's keep an eye on the GPU and CPU. I'm just going to touch it real quick. Something got real hot over there. Okay. I'm going to turn this down because that actually was too much current. We don't need that much, so we'll go down to 0.5. Five amps. Not seeing anything yet. So let's flip over the board and we'll do it on the other side because we know that these capacitors also have it right here. Oh no, it's that one's fine. This one has it. Okay. So where I'm touching is actually heating up. So right next to it. Let's put a little alcohol over here. We need to be able to isolate where the issue is. So I'm just gonna put a little alcohol in there. Is it that capacitor right next to it? Can you tell? Let's try it again. So more alcohol. I'm gonna touch it again. Yeah, you see how the alcohol is coming off of this? So stare at that. See how it's going off of it? And I think on the side I see something. All right, I'm gonna guess it's that capacitor. So let's go ahead and let's remove that capacitor and then we'll test again. I think it's kind of strange to have two capacitors at the same time have this issue. But again, it was, you know, keep your fans clean apparently, right? So this thing was overheating for a long time. So let me take that off and then we'll continue testing. Okay, I'm just moving it out of the way. All right, let's measure again and see if the short is gone. And there you go, our short's gone. So this capacitor right here was also cracked. So we had two capacitors cracked on this machine. One was on the main power rail, and one was on whatever this goes to. I'm not sure what it is, but usually it's going to be on one of the main power rails for the CPU or GPU. So let's go ahead and get that little capacitor replaced, and then we'll reassemble and test. Okay, just some fresh solder on those pads. All right, let's get the new capacitor installed. All right, the new capacitor is installed. We'll just clean it up real quick. We'll check and make sure the short is gone. Yep, and we're measuring in the kilo ohms. So no zero short there anymore. All right, so now we just need to plug this in and we can make sure that we are pulling that 0.01, 0.02. So let's keep an eye on power meter, 0.01, 0.02. There it is. So that means that the EC chip's coming on, the LDO's on, and that the power button, it will be able to listen to the power button. So let's go ahead and continue. I'll get this back together, and then we can continue testing. All right, so we'll put this back in here for the second time. And this time I'm very confident that's gonna work. Last time I was 100% confident, and that quickly turned into I should have tested it before I put it together. This time when we have two cracked capacitors, we found I'm still in the 95% chance that this laptop will turn on when I get it back together, but I think I was a little too confident on the first time around. So we will see momentarily. All right, motherboard is installed. Moment of truth. Keep an eye on the power meter. 0.02. Jumped up to 0.15, 0.29, or 0.23, and it should jump up. That's pre-charge current. I have the battery plugged in, so it should be jumping up to start charging the battery. The battery was pretty charged, so I'm not suspecting it actually will do full charge current, and there we go, we're at 1 amp, we're charging the battery now. So is the power button gonna work? And when we press it, I got the keyboard lighting up, and we got the power button lighting up. I hear the fan spinning up. And And let's see if we can get an Alienware screen. This is the first time turning on, so hopefully, a lot of times it will take a little longer, but I hope this is gonna work. I can hear the fan spinning up again. All right, we're pulling 4.2 amps. That's with the battery in there. And it keeps kind of cycling on and off, so hopefully this is gonna work. I mean, we did have a couple shorted components. Well, great. Okay, well, I'm not sure at this point. And there we go, we got an Alienware screen. The CMOS battery was reset. Let's boot into diagnostics real quick. All right, we didn't find any errors. And everything's working. It looks like it's charging the battery. It's running off the battery. Let's see if it boots up. Please wait. And now it's booting the Windows. And exception, invalid stack. Ooh, okay. Let's see if it will boot up normally. Not sure what that blue screen of death was. All right, looks like it's booting the Windows just fine now. It may have been it's still in hibernation or sleep mode, so it was trying to resume or something like that. Let's see if we can get the login screen. Well, I spoke too soon. Looks like the CPU actually did fail. I mean, this machine had been overheating for such a long time, and so no matter what I do, no matter if I try a fresh operating system, try to boot into Linux, I get this. The blue screen of death. And this one's a system thread exception not handled. I keep getting different ones. Sometimes I get a stack exception. The blue screens kind of switch out. I've tried different RAM, tried different hard drives, different operating systems, a fresh install of Windows. I've tried booting into Linux. No matter what I do, I keep getting different errors, and it all points to just a bad CPU. I mean, this Ryzen 9 had been overheating for such a long time, and I'm not even surprised at this point. You know, we had a couple, the capacitors failed. I mean, the fact that we had two power rails, two different capacitors and two different power rails fail, which blew my mind in the first place. But now it's starting to make more sense that this CPU was struggling. It was begging to be cooled down, and it was just overheating and caused catastrophic errors. So unfortunately, this motherboard's going to have to be replaced. I contacted the customer already, and this machine's like the highest end version of this board. It's a Ryzen 9 with a 3080, and so these boards are about $1,100, give or take, and the customer just wants to scrap the system. He's done with it. So unfortunately, I'm not going to be able to fix this, but here's what I'm going to do. So this needs to be mailed to the Gooch collector, and so I'm going to go ahead and get this packaged up. I hope the Gooch collector knows what to do with this. All right, so this is sent off. This was definitely a strange one, and it kind of threw me for a loop. I thought that the machine was fixed. It was kind of booting up. It passes all the diags if I run diags, but anytime you try to access an operating system of any sort, it fails. So I'd love to know your thoughts on this one, and thanks for watching.
I couldn't save this laptop.